Hi, everyone. So today I'm going to present to you a paper we published last year entitled Information Theoretic Characterization of Uncertainty Distinguishes Surprise from Accuracy Signals in the Brain, or The Curious Brain After Reward and Surprise Information Gain. So uncertainty is ubiquitous and pervasive. It can come from many different sources. So for instance, it can come from internal signals, where a stomachache can signal food poisoning or falling in love. It can come from the environment, where a cloud might portend a storm. It can come from other signals, where we might have to infer an emotion from a mysterious smile. Or it can come from time, because we live in a dynamic system. So for instance, we might have to take into account volatility when deciding when to exchange currencies. It comes in many forms too, such as expected or unexpected uncertainty. And so it generally presents a problem for both man and machine because it affects prediction, classification, decision making, and learning. Yet, humans have survived and thrived in spite of all this uncertainty, which suggests that there are mechanisms in the brain that are meant to resolve it. So, how does the brain compute uncertainty? How can these research efforts further benefit AI? So, when we talk about uncertainty in the brain, we often cast the brain as an inference machine or a hypothesis tester that integrates incoming information with prior knowledge, makes a prediction on that incoming information, and then fine tunes this according to the outcome. Now, remember that a brain will not expend, a healthy brain anyway, will not expend resources if it doesn't need to. So if a response arises, it must be useful. And generally speaking, when we study these decision-making variables, we borrow models from economics or the information sciences to formalize different variables. And one aspect of these frameworks is the emergence of surprise when expectations are violated. So these are, generally speaking, the prediction errors related to reward or uncertainty and so on. But what is surprise? So the answer might seem obvious, but we're still working on defining what it is to humans and to machines, what its function is, what its purpose is, and how to capture it. Because there are two facets of surprise, at least two facets. So there's surprise that represents a rare event, which is captured by Shannon surprise, but it could also be reflected in an observed behavioral change based on information gain. And there we talk about Bayesian surprise. So what we know about the brain with regards to decision making and uncertainty, well, the processes related to reward are pretty well characterized. And we also know that data-bound surprise or this outlier detection surprise is also reflected in a neural response. And there's also some evidence of Bayesian surprise in learning experiments. But what happens in a one-shot decision when an outcome is deterministic? Is there still a form of information gain? So we wanted to look at this question by performing an fMRI experiment where we elicited uncertainty via a gambling task. So subjects had to bet on whether a second card drawn from a deck of 10 cards was higher or lower than a first. The bet is made with no prior information when the probability of winning is 0.5. Then when the first card is drawn, we expect subjects to compute an expected reward and confidence taken as the negative entropy of outcome probabilities. Then when the second card is drawn, participants know if they've won or lost, and we also expect their brains to compute the reward prediction error, a surprise quantity related to the probability of the outcome, and we also look for an information gain in the form of a confidence error. So this is what we call accuracy in the title of the paper. And it's simply the truth, the ground truth, which we take to be 0, minus the confidence computed in the previous time epoch. Importantly, between trials, there's nothing subjects can learn. So there's nothing subjects can learn from one trial that they can carry over to the next. And here are the results. So first we looked at confidence taken as the negative entropy. And here we find that it correlates with a response in the hippocampus. Then Shannon surprise elicits response in the insula here and in the striatum. But information gain in the form of confidence error, so this is the very novel result, also elicits a neural surprise, which is remarkable because there's no explicit need for this information given that no learning can occur. Yet, it seems that the brain expends energy on calculating how far off the mark it was nonetheless. And these are strong effects. So in model-based fMRI, uh, the results, I mean, there's an argument that the results might be subtle because it's a cognitive effect. It's rather abstract. It's not related to a behavioral response. It comes from a noisy signal, and of course, we have to do multiple corrections because we're running multiple tests. And yet, we find these strong effects nonetheless. So this is worth sitting up and paying attention to, in my opinion. Now, what are the implications of these results? What does it all mean? Well, if the brain signals an information gain even when there's no need for learning, then it provides some evidence that the brain is curious and it likes to hoard information, maybe for some far off future event. And this characterization of brain processes relating to uncertainty may help with efforts in artificial intelligence if the latter look to emulate human intelligence. And we often talk about neuroscience inspired AI, but here, we can see that it's something of a circular economy where cognitive science inspires AI, which in turn inspires cognitive science, and so on and so forth. Finally, the results here offer some opportunity for thought experiments relating to AI. For instance, should artificial agents model all these errors and forms of uncertainty? Does an artificial agent always need this stimulus bound surprise, this Shannon surprise, or is information gain sufficient? And so, with this, I thank you very much for your attention. The link to the paper is here. And if you have any questions, please feel free to email me at the following address. Thank you very much.